Hi.
Formula for resistance in a wire.
There is resistivity times length over cross-sectional area.
Yep. Last week, we are very productive. We do one test paper plus half, which is paper 1 PS. Yeah. Did you do PS paper 2? Or what did you do?
Junyuan.
Oh, Junyuan. Oh yeah, you do Junyuan because yeah. Because the PS is only when you okay. How come I put field glove here? Okay, Junyuan. Okay, you already upload there?
I did it like online.
Oh, you did it online. Okay. Okay. Paper 1, how much you get? You haven't marked.
I thought you marked.
I marked. No, the one that I marked is PS. This is not bad. This is not my handwriting. It's mine. Oh, I checked. Six, right? Junyuan haven't marked. This is not me. Oh. Okay. Okay, never mind. We mark paper 2 first. Yeah. We mark paper 2. Okay. Oh, so deep down here. Okay. Okay. 800 kg. Oh, okay. The answer key here. For 25 kilometer per hour. Yeah. Vector speed is scalar. Okay. This one is okay. 1520. Okay, good. Total is 4 marks, right? Okay. 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 SSL. overcome his weight. Yeah, correct. Weight of his own body. Chemical potential energy. Yes, that chemical is from. Oh, you take bio? No,
No.
don't take. Oh, okay. That chemical, the chemical energy is from a substance in the muscle. Yeah, and the name of the substance is called ATP. So every muscle in your body contains this substance called ATP, adenosine triphosphate. Then when you use it, you lose the ATP. Then how come you can still moving? Because there will be energy from other source, from the cells, from the what do you call it? Respiration of the cell. You have oxygen, then produce back the ATP again. That's it. Yeah. So when you feel tired, it doesn't mean that you don't have any glucose. You have glucose all over your body. Yeah. But you're lacking of ATP here. So that's why you feel tired. Yeah. This one, 400 Newton. Yay, 200 Newton. Very good. Yeah. Wow, put a weight on his face. Very good. Okay. Put his weight. Okay. Okay, can. Yeah. Or you use his knee. Yeah. You use his knee to increase his so that the distance okay, sorry. Put the toes higher. Yeah, so it's more difficult to go up. Yeah. Okay. Correct. Wow. Total is nice. Yeah. 4, 5, 7. Wow. 7 out of 7. Okay. Okay. This thing is your favorite. 0.98 mm. Wow. Correct. 7.69 gram per cm. Very good. Okay. Thickness of the metal plate may not be uniform. Very good. Yeah. You measure. Yeah. You measure several place. Yeah. Then you take the average. Wow. Nice. This is total is 4 plus 3, 7 out of 7. Wow. Okay. Question more. 10,000, 107,000. Yeah. Height of the mercury. Age decrease. Yeah. Yeah, correct. Okay. Because the H is the difference, yeah, and the difference you get less difference. 4 out of 4. Okay. Okay. Point E, where light rays into F and C. So total internal energy. Correct. Very good. Yeah. Okay. Label the critical angle. Oh, yeah, correct. Yeah. Okay, correct. Yeah.
I'm still a bit confused why there's still a ray.
Oh, okay.
Just,
It's like this. It's like this. It's like this. Whenever you have from denser to less dense, you have reflection, right?
mm,
Let's say it's smaller than the critical angle, then you have reflection here. So this is I and this is R. This is not true. Some of it bounce back.
oh,
So this thing is called partial internal reflection. And it happens all the time. You go to a shop. The shop have some nice showcase with glass in it. Well, then they make it very nice. You see a reflection of yourself. You still can see through. You still can see the object. Yeah. You see the product on display, but you see yourself also. So it's partial. Some of it can pass through, some bounce back. Yeah. Now, total internal reflection means if it is bigger than critical angle, then it's 100% bounce back. There is no zero possibility of getting passing through. So that's why they call it total internal reflection.
But then
that means when you have refraction, you have partial. You go to any shop, not shop lah, any window, yeah, any window on the shop or any window, you can see a reflection of yourself, whether it's very obvious or not so obvious, but you can see it. Yeah. Okay.
So is the
If it is exactly C, then in theory, okay, first of all, there's no such thing you can get exactly C. You cannot get exact what you either a little bit too big or but in theory, if you can get C, exactly C, then it's exactly 90 degree. It's some of it will be 90 degree come up.
So the ray is the weak reflected ray.
Yes. Yeah. And how many percent pass through, how many percent depends on the glass, depends on the frequency. There's a lot of other things. Yeah. For us, we learn the easy one only. We just say that it is partial. Yeah. Complete ray for Q. Yeah, and pass through. speed of light? They don't give the angle. Oh, it's 45 degrees. Okay, 45 degrees. 8.12. Eh, how come? How come so big? Or 2.12. Your 2 looks like it. 2.12. Yeah. So total is 4. 4 out of 4. Okay. Okay. Wavelength 2.5 meter. Very good. Wavefront. Hey, cannot. Hey, cannot like that. Hey, how come? Hey, it would not bend. It cannot bend.
Oh, last time we drew then it bent.
No, it is bending, but in this case, this is the normal, right? That means the I is 0.
Oh,
You don't understand.
so like the if the
This is the
arrow
normal line. This is the normal line. Then this is the incidence angle is 0. So I is 0. So it's still straight. Then you just need to draw shorter or longer?
shorter.
Shorter. Yeah. This one. But this is correct here. Decrease. Yeah. 3 out of 4. Yeah. You're taking higher mother tongue.
No.
Oh, this is difficult, right? Chinese is difficult. Right. Then so you cannot -2.
Yeah.
Okay. Small drop of oil. Wow, this is experiment. This is the Millikan oil drop. Oh, sorry. This one I haven't explained here. You draw this way, yeah. Okay, continue but shorter, like this. Yeah. And it's like that. Okay. Okay, where is it? Type of charge carried by the oil drop. Positive lah. Yeah, correct. Okay. Direction of motion. Yeah, correct. Correct. 4 out of 4. LDR here. Oh, this one. You saw this all the time. Soap dispenser is using the LDR to trigger. Yeah. LDR is high resistance when it is
Cold.
dark.
Cold. LDR, yeah.
That one is the mix.
Yeah.
Okay, good. 3000. Okay, let me check here. Okay, there's the 3000. Okay. .5 volts. Okay. Okay. Okay, good. 7 out of 7. Okay. Then the magnet here. Yep. The magnet here is, you draw this way. This way. Up. Yeah. Okay. You understand already. Yeah. Correct. Wow. Good. Together if they are attracted to each other. No, this thing is cannot. You know why? Very simple. You have two nails. Let's say one of them already demagnetized. One of them is still magnet. Then they will still attract.
Because it's magnetic material.
Yeah. You to prove that something is a magnet, don't use attraction. Attraction, you still have the possibility. You use repulsion because only when it is magnetized then it can get repelled. Yeah. If something is made of iron but it's not magnetized, it still attract. Then if it is repulsion, you repel. Confirm something is there. Yeah, that means you use a magnet. Then you try the nail find a position until it can get repelled. If it can get repelled, that means you still have some magnet in there, either knock or sound. Yeah. Describe demagnetize. Oh, okay. In and out of. Okay. You don't have to put in and out. Just put it inside. Yeah. And leave it for some time. Yeah. Then when it's still turned on, when it's the alternating current is still here, you pull it out. Don't turn it off first, then pull it out now. When it's still on, you pull out. Yeah. So its total is 7. 5 out of 7. See, the way we mark is very, very fast, right? Because you make very little mistake. And that's why it's very fast. Oh, this one. Natural gas is run in a combustion chamber and hot gases. Where's Sanoko? This Sanoko, they mentioned about the Sanoko power station. Where is it? You don't know.
Me, Singapore.
Yeah, of course it's Singapore. Where? Don't know.
Wrong.
Woodland.
Yeah.
They have industrial complex, then they put one. After the O-level, you should move around Singapore. You know where is Singapore Singapore port? Where is it? Don't know. Where is it? It's a big part of Singapore identity. It's in Keppel. Keppel is in Tanjong Pagar. Tanjong Pagar. Yeah. It's a very Singapore port is very important. 7% of our GDP from there, from the port, which will increase. That percentage will increase because later they're going to shift to us. Then they make a very big. I'll show you. Tuas Megaport. You really need to move around Singapore. Tuas Megaport.
Oh.
Bigger. Singapore used to be number one in terms of the number of containers coming in the whole world. Then in 2000 something, 2016 or 17, then Shanghai overtake. But in the future, this thing, Singapore will be number one again using this one. It's good. It's good. They make a lot of money. It's very important. Yeah. So you have power station in Singapore. We have two. One is in Senoko. One is in not one. You have 4 there and like 7 in Tuas. Yeah. Blah 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 blah. Steam. Yeah. So basically, you burn the natural gas. You burn methane. Then you get then you produce heat. Then you use it to power the generator. But you still have heat release. Now heat release, you don't want to release that heat so easily. You try to extract more energy out of it. So you put you're taking in steam. Yeah. Whether it's a little or a lot, we try to get as much energy from that. Yeah. The steam process which can be converted without burning. This is because the heat that we take in is okay. Yeah, you must mention that this thing, the steam can be used to power the turbine. Yeah. Something like the steam is being used to power the turbine. Okay, never mind. Yeah. Then I can read here. I think you -1 here. Okay. Describe how hot gases to the motor. hot gas to the water in the heat recovery. Or they say yeah, heat energy is transferred. Then you say by conduction through the metal pipe.
Oh.
Yes, and because they say it's transferred. This is okay, convert. Okay, convert. But transferred is from one object to another object. Convert is yes. Okay. But the one that they ask is transfer. So transfer of heat. So this one is for conduction. Yeah. Okay. Conduction through metal pipe. Then internal energy. Since kinetic energy is lost to the water molecule, internal energy decrease. Yeah, correct. Why energy is needed to produce steam? And it's intermolecular force of attraction. Yeah, correct. 175 megawatt. 850 megawatt. Bracket 1850 megawatt. Wow, total 3, 5, 6, 8, 10. You only lose 2. Yeah. Oh, this one. This is the DC motor. This type of ring is called something?
The slip ring commutator.
Slip ring only.
Oh, really?
Commutator is the split ring.
Okay.
Yeah. Okay. AV goes up, CD goes down. Wow. Very good. CD down, AV up. Wow. Clockwise and then anti-clockwise. There's a fault. Okay. Yeah, every 180 degrees, correct. State the solution. The motor can use an alternating current. Okay. Okay. It's correct. But you cannot say that, you know. Because in the because the one that you have is a DC source. The one that you have is a battery. I said that means you're asking the person to connect it to AC current, yeah, which means you're changing a lot. Yeah, that means the one that you should change is not the current, but something else. The ring. Don't use this ring. Instead, what you use? What ring you use? Split ring commutator. Yeah. Yeah. So if you change the current, if you change the power source, that means you're changing too much. Might as well ask them buy the new motor. But cannot do that, that means you're changing a lot. Okay. But it's correct. If you connect to AC current, it's correct. It will rotate. Yeah. Wow, good. 3470. Oh. Watts. 1250. Yep. 4, 6, 7, 10. You lose 2 out of 10 also. Wow, nice. You're doing the either. Hair dryer. Water from wet hair. Purges from air, which increase the temperature. Water. Okay. Very good. Yeah, then the red. Okay. Oh, then they give you all the data here. 1920. Very good. 59.9 degrees. Wow. One assumption. No heat is lost to surrounding. Yeah. S. Reduce the current. It will reduce the current. Oh. No. It's a trick question. Oh. S connected to Y. S connected to Y. And it's not connected to X, then you have more resistance, yeah. Which means the motor is getting slower. The heating element is fixed. The heating element is 240 volts all the time, never change.
Then what's the point? Then what's the point of switching it?
You want to slow down the motor.
Why?
You're using a hair dryer. You want to control. Sometimes you want the wind to blow faster. Sometimes the wind will go. You want the wind to go slower.
Okay.
So the air will be hotter or colder?
Cooler.
Huh? Cooler.
Colder.
No, hotter. Because the amount of air that you put inside the heater is less. So the same amount of heat energy is concentrated on a smaller amount of air. The temperature is higher. Understand? Like you give the same amount of heat to small amount of water or large amount of water. If you concentrate all the same amount of energy on a small amount of water, then it's hotter. Yeah. Okay. You use water heater when you take shower.
Yeah.
You use cold water or hot water.
Hot.
Then you have then you can control the the temperature, right? You make it hot. Let's say you don't change that one, but you make the water go slower. What will happen? The water will go hotter or colder? You don't understand.
Wouldn't it be colder?
Hotter.
Why?
Because you have less water. And all the heat will be concentrated there.
Oh.
You never tried?
Oh.
Next time you take shower, you try. That means you keep it fixed. The water heater, you make it fixed, but the amount of water you make it less. Then it will be hotter. Yeah? So this is the same principle apply here. That means this resistor is connected to motor, not the heater. Yeah. This thing. Total resistance increase and thus this is the wrong part is here. Yeah. Okay, minus 2. Okay, is it 10? 4, 7, 10 minus 2. 8 out of 10. Okay. 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 Today's date is
11.
11. Oh, okay. Your mark here.